Hey A&Pers, this is Dr. Jones checking in. This is A&P 1, Lecture Test 5, Video 12, covering page 14. First, let's talk about the generation of action potentials. Let's go through this picture, which is on your test. And number 1 here is this first segment from here to here. And this is depolarization to threshold. We start at resting potential, which is negative 70 millivolts, and bringing that up to threshold, which is negative 60 millivolts, is this first segment, number 1. The second segment, number 2, which goes from here up to here. When you reach threshold, that opens the activation gate on the sodium ion channels, voltage gated sodium ion channels that we saw in on another slide. We saw here. See, we had voltage gated sodium ion channels. We had an activation gate that opened at negative 60 millivolts, which is threshold, and then it closed at peak voltage, which is plus 30 millivolts. Okay, so this is what we're talking about. We've already drawn this out, looked at it. So there it is. That's not what I wanted. Never. Okay, so this is number 2, where the voltage, the threshold, opens the sodium channel activation gate and sodium ions are rushing into the cell. Is number 2. Sodium ions are rushing into the cell. Because the sodium is positive, then this goes up because it's like we're paying off our Kohl's card, right? You're putting money on the Kohl's card, $1 a day, or pretty fast actually, and it goes. You get less negative. You cross 0 here, and then you actually have a credit on your Kohl's card, meaning you can go and just buy $30 worth of stuff. It's already paid for. Fun, right? Okay, so the sodium ions rush into the cell, making the inside of the cell less negative, which we call depolarization. Excellent. Now let's see, let's change pen color. We don't have purple, so we'll do magenta. Number 3 is peak voltage. Peak voltage. At peak voltage, which is plus 30 millivolts, of course, 2 things happen. One thing we've already talked about, it closes the inactivation gate on the sodium ion channels. So you got no more positive ions rushing into the cell, so it stops getting less negative, or in this case, more positive. Okay. The second thing that happens is it opens voltage-gated potassium ion channels. Well, we haven't talked about those yet. Okay, so in the axolemma, you have both voltage-gated sodium channels, and those are the ones we saw. They've got an activation gate and an inactivation gate. And you have voltage-gated potassium channels. And they open at peak. Which is the opposite of the sodium channels, which close at peak. Okay. 2 kinds of voltage-gated ion channels in the axolemma. The sodium ion channels, the inactivation gate closes at peak. Also at peak, the potassium ion channels, the voltage-gated potassium ion channels, open at peak. All right, so that was number 3, which is peak. So now that we're no longer depolarizing, because we no longer have sodium ions rushing out of the cell, but we do have potassium ions. And which way do potassium ions go? Potassium ions rush out of the cell. And there are also positive ions. So when the positive ions leave, we get repolarization, where we go back down. Okay, gets less, more negative. It gets more negative. Okay. And then 4, that's entirely not the button I wanted to push. Try again. Blue. There we go. So 4 here is when you close the potassium channels. Now when the sodium channels close, they close fast. They're a fast channel. And when the potassium channels close, they close slowly. So as they start to, they're like closing slowly. And since they take so long to close, you have this, because here was your normal right here, we dip lower than normal. So we have this brief period of hyperpolarization. At the end of the action potential. Now, anytime you hit threshold and make an action potential, it automatically depolarizes. This is different than a graded potential, which can depolarize or hyperpolarize. But an action potential always depolarizes. Now there is a brief hyperpolarization at the end, but that's not what it does in response. Its initial response is to depolarize. Okay, so, in case you need that for some, random test question purposes. So, there we go. Hyperpolarization. So that's number 4, close the potassium channels, resting potential is restored. Excellent. And now draw that. So I'll draw it with you. So we start at -70. We'll add a little millivolt. Okay, start at -70. And then number 1, we're going to depolarize to threshold. What's threshold? -60 millivolts. Depolarize to threshold. Once we depolarize to threshold, we're going to whoop right up to the top. So 2 is depolarization. And what causes depolarization? Reaching threshold has opened the activation gate on the sodium ion channel, increasing sodium permeability, allowing sodium to rush into the cell, causing a rapid depolarization. Until you hit number 3. What's number 3? Peak voltage, which is +30 millivolts. So I'm right on the +30 line. Okay? 2 things happen at peak voltage. We close the inactivation gate on the sodium ion channels, the voltage-gated sodium ion channels, and we open the voltage-gated potassium ion channels. So we stop going up and we start going down. Okay, and we go further down than resting was -70. We're going to go all the way down to -80-ish and then back up to -70 to return to resting, because the potassium ion channels close slowly, so you're still leaking potassium out after a little bit after you kind of need to, although we kind of do need to, which we'll talk about. So you do have a brief hyperpolarization at the end of the action potential. And again, if you depolarize but not to threshold, none of this happens. You have to get all the way from -70 to -60, which is a change of 10 millivolts, or none of this happens. But every time you hit threshold, this whole thing happens. You can't make it stronger or weaker. This is just the response. This is what it is. Let's write that. Okay, so let's talk about the refractory periods. The rules for starting an action potential are different during the refractory periods, and there are 2 of them. During the absolute refractory period, action potentials absolutely cannot be generated. This is due to either the sodium channels are already open or they're inactivated. Let's see, let's make this a highlighter. I'll do it on mine. Okay, theirs is pink. Okay, pink highlighters. Pink. So we start at threshold and we go till about -40. Okay, so about like that. The pink area is the absolute refractory period. Absolute refractory period, where you absolutely cannot start a new action potential. The sodium ion channels are already closed, already open. You can't reopen them. Or the inactivation gate is closed and you can't open that. You have to open the activation gate to start another one. Okay, next is the relative refractory period, where action potentials can be generated, but it's harder to do. So there you go. The relative refractory period includes the hyperpolarization till you get back to resting membrane potential. It's okay. Say you only buy more clothes at Kohl's when you owe $70 or less, and you owe $70. Or you only owe at 60 or less. Let's make it threshold. You only buy more Kohl's clothes when you owe $60 or less, and you normally owe $70. So you pay off $10, and then you can buy more clothes. But what if you owe $80? Then you're 20 from 60. So you have to pay $20 off to be able to buy more clothes. So you're just that much further from your goal. So you can still do it, but it's harder. Okay, so that's what hyperpolarization is during the relative refractory period. You can still start, oh, highlighter, it does work. You can still start an action potential, but it takes more doing. It takes more to do it because you're further from your goal. Okay, how does this relate to flushing a toilet? Okay, if you have just flushed a toilet, you cannot flush it again. You absolutely cannot flush it again for a short period of time. This is the absolute refractory period. And then for a little bit after that, you can flush it again, but you gotta like really jiggle it. That's the relative refractory period, where you can flush it again, but it's harder to do. On that note, this has been AMP1 Lecture Test 5, Video 12 on page 14. Thank you as always for tuning in. The education and the toilet flushing must go on. Dr. J out.